In this video, we will talk about the index addressing. So then we will revisit our copy string source file to see, besides we're using the loop, but we will use indirect addressing to traverse around all the elements in the array. So what do I mean index addressing? So if you remember in C++ or Java, when we have the array to access, we use the index to access each element in the array. So did you remember that square bracket? So can we do the same thing in the assembly language? For example, you see we create one array. It's called A. So then we just need to using the A square bracket to access each element. Yeah, so before when we show you, you're only using the ESI to traverse around, right? So that one is we call the indirect addressing. So now actually in assembly language, you can use the square bracket to access. So we see what's that index addressing. So the index operand, actually you add a constant to a register to generate effective address. So there are two different formats. You can have the square bracket. You're just using the label plus your register. So here the label means data label. So the register can be ESI or EDI. But now the ESI, EDI, we don't using the offset for the data label. We just have the register like EDI, ESI start from 0. So you can either using the data label to plus the register, or your data label can work like array in C++. So then they follow by the square bracket. So they have the register value here. So on the other hand, your index actually just like associates in the square bracket with your data label. We see what does that mean. So again, we have our array W, array W word. So if you remember how the array look like, right? Okay, but now we don't do the ESI yet. Okay, so one thing is you have your array W. So if now we're using this array W as the label, so we're using the index addressing. So now actually the ESI now is not really point to the location where the array W is. So instead, this EXI actually start from 0. Okay, so you start your EXI equal to 0. So then every time you want to access that, right? So we're using the indirect addressing. So your indirect addressing just using for the label array W, okay, to plus your ESI. So that's the first one. So then here you can either do this one to using the plus. So array W plus ESI equal to 0. So then they still refer to this value. Or your ESI can be the index in the square bracket. Okay, so either this way or this way, they all mean the same thing. So then here, actually your AX just equal to 1000. Okay, so now here we add ESI by 2. But here it's better we write type. So we use the type array W, so that's 2. Okay, so then afterward you see your ESI increment by 2. So that's, I say it's different. You can use in the index addressing, but index addressing in assembly language, they mean the offset, the difference before, after your data label. So here the next value actually is not 1. The next value is really because here is 2 bytes. So your 1000H is 2 bytes. So we add 2 bytes. So now your ESI, actually the next one become 2. So then you add the array W. So that's why when ESI equal to 2, they point to the 2000. So then you move the AX. Okay. So that's why we call the index operand. So the index operand, you can either have your register within the square bracket, or you can just using the array W plus your regist, then you dereference. So I want you to see this example. If we change to the D word, what will change? Okay, so if that D word, yes, I still start from 0. But here, because this one, we're using the type, so that's why they will be 4 byte. So that's why you see here, instead of manually use 2, it's better you will just using the type. So they always can copy, they will get the correct element size and save to the regist. So on the other hand, you see after you know the index operand, right, we can using that for the sum of array as well. So you will see a little different. They are similar concept. If you have your int array word, you have 4 elements. So you see before your ESI start from offset for the int address, int array, right? So before we call that the indirect addressing. So here when we're using the index addressing, your ESI actually start from 0. So you want to write the loop, so they still need to have ECX. So that's the word. So we use the AX as a sum. So every time when you have each element one by one, right, you start with the label name, square bracket, have your index value. So we start from 0, so they will access the first element. But afterward, when you increment your ESI, right, yeah, because no matter you use the indirect addressing or you're using the index addressing, they're all using the type to add the ESI to visit the next element. So this one is index addressing. So index addressing means your square bracket associated with this index. Then you have the label before that. Earlier, we talked about indirect addressing. Even we're still using the regist. But this regist actually will be the same location as the beginning of the data label. So that's we're using the offset for the data label. So that's indirect addressing. That's only the memory address. So then when you want to access the element one by one, you need to do the dereference on this regist. So that's the difference between indirect addressing and index addressing. So let me show you the highlight in the purple. Okay, so in the purple, indirect addressing, you have the EDI regist is the memory location for the data label. So then when we find the value, we dereference the regist. But index addressing is, you see your regist start from 0. So then every time when you want to access that, right, you need to using the data label. You're still using the original data label, but associated with the square bracket to access element one by one. Okay, so after you understand the index addressing or indirect addressing, I want to revisit our copy string. So our copy string file, so you see earlier in your lab exercise, your copy string, you have one source array. You have your target array. But you see here, we're using the indirect addressing, have your 2 registers, ESI, EDI, direct refer to the memory location for the source array and target array. So that's the indirect addressing. But now here, I want to rewrite this example, become the index addressing. So how they will look like. Right, if you find out, if you want to change to the index addressing, right, they all start from 0, right? So that's good. You see earlier, for the indirect addressing, I need to have 2 registers to point to the beginning of the array. But now if I change to the index addressing, I still using the source and the target as a label. But the EXI or EDI, they just start from 0. Then they traverse to the next element. So on the other hand, they will look like this. So here we still copy the string from beginning to the end. It's different from your lab exercise, you reverse. But of course, you still can do the reverse. Then you just need to see how you will do that. So that's why here, earlier, when you do the indirect addressing, you need to have ESI and EBI. But now we don't need, because index start from 0. Okay, and also your source and target, they have the same element in the array. So then you'll see, right, your ECX will be the size of the source. So you can be size of, you can be length of. Usually we do length of. But this one, because you are byte array, so I can do the size of. So then when you want to copy over your source to the target, right, they both are memory operand, right? So then we need to have a AL. So this AL is the temporary, the character holder to hold the element from the source to the AL. So now you have your AL to copy over to the target. But the most important thing is what? Okay, so here actually is typo. Your source using the EXI start from 0. But when you move to your target, actually the same thing, you're still using the EXI because do the 0 to 0. Okay, so then after you're done, right, you increment EXI. This one using an increment because that's a byte. The best actually you should do is you can using the add EXI, but then you use the type. But anyway, that's all okay. But the most important thing is you will see the difference between the index addressing from the before we use the indirect addressing to copy the string. Of course, make sure you will run this program on your IDE. So then let's see here when we run the IDE how they look like. So let me close the window. Okay, so we are running the copy string.asm file. So we still have the beginning, we have our source and the target array. So then, right, see, before our loop, okay, we just need to have the ESI start from 0. So the ECX here, you can check. You can do the size of, you can do the length of, they are all the same. So then we just need to using the index addressing. ESI start from 0, I copy from source to the AL. So then from AL, I will copy to the target. So afterward, you see you increment your ESI. So after they do so many times, so then you will have the target array have the value as the same as your source array. So we see if they run correctly. So again, because that's the string array, right? So then here, when we do the start debugging, oh, sorry, I forgot to have the, yeah, you need to have your breakpoint, okay? So after you have your breakpoint, so then you can start debugging. So then I need the memory window. So the windows, I go to the memory window. Okay, so in the memory window, you need to give them the location. So we have the source. So then you will see, yeah, that's a source string. So continue. We just actually skip the whole thing. So you will, after you're done, you already go to the, no, here actually that's just the first loop. So that's why you see the T is copy. So you do one by one. Okay, so that's why you see each one they copy over one character. So we're using the index addressing. Okay, too fast. Okay, so then afterward they done. So I will run again. You see here, they add one by one. So until the last one, you copy the source string. Okay, so that's why you have your target on the target array have the same copy. Yeah, so different thing is we're using the index addressing instead of the indirect addressing from the previous example. So make sure you will download the source file and run.